In this subchapter 6.6, we learn about data center networking, and we can understand how that center is configured for the Google data center and the Facebook data center briefly. Here, this one is the only example, and this one is Chicago data center of Microsoft, and this one is modular data center, container-based modular data center, 40 feet, that is around the 12-meter container, and in that container, around a couple of thousand servers hosts are integrated, and they are interconnected. Here, this switch on the top, and the others are servers probably, and those hosts are interconnected, and this Ethernet speed is around 1 gigabps or 10 gigabps, depending upon the availability of that Ethernet technology at this moment when that is being manufactured. And the backbone is around 40 gigabps or 100 gigabps. And this is called blade because that is inserted here and in that slot, and that is in terms of the figure, that is different from plain desktop. This one is blade, and each one is server, Microsoft Windows Server or Unix Server or Linux Server. Okay, this one is Ethernet cable, and they are interconnected, and also this is called rack, and on the top that is called top on the rack. Usually switch is there, and also those switches are interconnected, and we learn that configuration after this slide. Okay, before that, let's look at this one first. This one is about data center networks. Tens to hundreds of thousands of hosts, often closely coupled and in close proximity. And that is mainly to provide that e-business like Amazon, Elastic Cloud Computing. Amazon is providing cloud service, and many other companies are also providing that cloud service. In Korea, one company, that company's name is Megazone. That company is providing that service of these Amazons and others. And content servers, for example, YouTube, Akamai, Apple, Microsoft, or even Facebook, those contents for social network service. And this one is video stream service, YouTube video, and many content providers. That service is being provided based on this data center, and usually this data center is modular data center based on this container, this container-based modular data center. Okay, search engines, data mining, for example, that is main business of these companies, and YouTube, that was merged to this Google.com, and Google is owning that company, and this company is providing that service also. Challenges are here: multiple applications, each serving massive numbers of clients to the worldwide customers. Worldwide, they are providing that service in real time. Managing and balancing load, avoiding processing, networking, data bottlenecks. And the data center architecture, data center network architecture, and that data center network design, that is very important for these major cloud service providers. Okay, let's look at a little bit more about these data center networks. Load balance here. This one is here. This one is explained about that. This one is application layer routing, providing that. And this one is receiving external client request. Client request here. And the directs workload within data center, and returns result to external client. after getting some result, and it is going out through this load balancer. Thus, in that case, this one is hiding data center internals from client. Also, the IP address here, usually those are private IP address. Outside is public. Thus, we need NAT functionality, and this load balancer is doing this NAT functionality. In terms of hierarchy, this is border router, and this is the tier 1 switch. In terms of hierarchy, we can call this one is tier 1 switch, and the tier 2 switch. This one is providing higher performance and more expensive. Tier 2 switch, this one is dealing with several Tor switches here, up to 16 usually. Also, this one is later, we can see that up to 16. Tier 2 switches will be covered by this tier 1 switch. Also, tier 2 switch will take care of that, Tor switches. And this Tor switch, those are all Ethernet switch. And here, the servers, around 10 to the 20 or 40 servers are here. That is called the blade, because that can be inserted here, like some slice, and that can be put in here, and that can be connected to that backplane bus interface. Those are called server racks. This is the hierarchy of this data center networks, and we can have more load balance here, and this is called access router. Higher one is, in terms of hierarchy, a border router to interconnect to other network, internet. Also, this one is showing, but this one is providing rich interconnection for reliability. Rich interconnection among switches, LECs. Here you can see more lines here. This one has more interconnection links. Thus, this one can provide increased throughput between LECs, because this one is providing multiple routing passes possible. And this one is providing increased reliability based on this redundancy. To get higher reliability, better reliability, we need some redundant devices. That is called redundancy. And here, to reach this one, if this one is wrong, and the other path route can be used. In terms of reliability, that is more reliable based on this redundancy, redundant links. Also, okay, we can see better configuration later with other slide about that. And now here, let's try to complete this one. This one is tier 1 switch in terms of hierarchy. Also tier 2 switch, and this one is Tor switch, top on the rack switch, and they are server racks here. Okay, let's move to the next, and probably this one is the final subchapter in this chapter 6. Also, this chapter 6 is the last chapter in this semester. Thus, if we are completing this one, then we are completing the whole chapters and completing this semester. A day in the life of a web request. We can understand the whole protocols which we learned so far, and they are all integrated together, and that is called synthesis. Synthesis means integrated. A day in the life of a web page. That's different from analysis. We are trying to understand the whole thing together, integrated thing together, based on this synthesis. We just learned each one by one. but we need to integrate them together. Here we can learn that integrated things together. Let's look at this one. Journey down protocol stack complete. Until now, we learned application layer, transport layer, network layer. In this chapter, we learned about link layer, data link layer. And let's try to put them all together. That is called synthesis. Goal is to identify, review, understand protocols at all layers involved in seemingly simple scenario. Simple scenario is very simple. Just trying to get some home page, World Wide Web home page, google.com. Here, scenario is like this. You, or student, attaches a laptop or notebook or smartphone, it doesn't matter, to campus network. And requesting and receiving this web page. So simple. Okay, let's move to the next. Here, this one is showing that scenario. You are here and you are just joined this network using your notebook or smartphone due to Wi-Fi that is available, we are assuming. And here you are trying to type google.com and you can get that result on your screen here in your notebook. That is so simple, and we can see that result so fast. But inside, many protocols are related and they are working together to show that simple web page. And we learned so far many different protocols and how they are working together and how they can show finally. And we can see this one in our notebook here to understand better based on these synthesis. Okay, this is school network with a certain IP address, subnet path, 24-bit, and this is switch, and this is router, and many routers on the way to the google.com app server here. This is Google's network with a certain IP address range. Depending upon the network, each path may use different subnet and different subnet bits. Okay, also we are assuming the DNS server, we need this one, and that is belonging to this Comcast, Internet Service Providers network. Okay, let's move to next. Okay, here, a day in the life, connecting to the internet. Okay, let's read this one first, then look at this one later. Connecting notebook needs to get its own IP address. To use internet as we used already, we need to set up first. Thus we need our own IP address for my notebook and address of first hop or gateway router and address of DNS server we should provide. And probably you are very familiar with that. But automatically, let's try, because that will be more convenient, and usually we are doing that. Thus we are using DHCP instead of self-configuration by ourselves. We are using this DHCP here. DHCP request encapsulated in UDP. DHCP is using transport layer protocol UDP, and that will be encapsulated in IP like this. We are using DHCP, application layer protocol, and this one is using UDP, and this one is using also unique IP address here in this network layer, IP address. This one will be used, and Ethernet protocol that will be used. And in each layer, you can see this segment and this datagram and this header will be added header, and those will be coming down here, and that will be used as a data, and another header in each layer's header that will be attached. In physical layer, nothing, just simply it is transmitting. Thus that will be transmitted through this link. Okay, DHCP request encapsulated in UDP as we learned here, and also encapsulated in IP, encapsulated in IEEE. Always that is omitted, but that is standard by this IEEE organization. Thus IEEE 8.3 Ethernet, this one. Ethernet frame broadcast. Initially it is broadcasting because it doesn't know the IP address first. This one is here, that will be broadcasted. Destination address, all one in terms of hexadecimal F. 1 byte, 2 byte, 3, 4, 5, 6 byte. Because Ethernet address that is using 6 bytes, 48 bit, all one. There's this one is FF, just like that. Receive that router running DHCP server. If that router is usually and also normally that is able to provide this functionality, DHCP functionality, also NAT functionality usually, and we are assuming this one is running here in this router. And if there is no DHCP server in that same subnet, then we cannot use this DHCP. Thus we cannot configure automatically the IP related information for internet. And here Ethernet demultiplexed to IP, and that means that it will be coming up to the upper layer, and finally that will be arrived here, DHCP. And let's move to next. DHCP server formulates DHCP acknowledge containing client's IP address of first hop router for client name and IP address of DNS servers. If they are this subnet is holding many DHCP server, and if there are many DHCP servers and the same thing is happening, but one of the offer will be received, and finally that will be selected, but those things are not explained here. Simply we are proceeding here to the next step. Encapsulation at DHCP server, frame ported through LAN. This DH server is providing that information, and that will be delivered to this client. And the DHCP client, this notebook, my notebook is DHCP client, receives DHCP acknowledge reply like this. Client now has, my notebook now has IP address, knows name and address of DNS server, and IP address of its first hop router or gateway router to use internet. Next step. Next step is using ARP. Before sending HTTP request, need IP address of this google.com, and DNS will provide that IP address of google.com. Thus DNS query that should be created to resolve that google.com IP address. And that DNS query that will be encapsulated in UDP, because DNS, this application layer protocol DNS is using UDP protocol, and that will be encapsulated in IP here, encapsulated in the Ethernet to send frame to router, need MAC address of router interface ARP. To send that frame, that should be in the Ethernet frame, but in the Ethernet, let's remind, Ethernet, we need some physical address, Ethernet address, to send through that router. Thus we need MAC address of router interface, this one. We need that MAC address, Ethernet address, or physical address, to make this Ethernet frame to send to this router. Here, ARP query broadcast. We don't know initially, thus we are sending broadcast message. Thus in this subnet, all devices will receive, because that is the broadcast frame. That will be received by router, and one of them, recipients, that will be router, and which replies you to ARP reply. And this one is providing that MAC address of router interface. This one is providing that information to make that Ethernet frame completely. Now, my notebook knows MAC address, Ethernet address of first hop router. This is the first hop router. So can now send the frame containing DNS query. Thus, this one can send this DNS query. Before that, we need that. Thus, we used ARP to get that MAC address, and we can send that DNS query message. Okay, here we are learning still that procedure, and still we are learning about the DNS operation here. Then that DNS query, okay, here let's read this one first. If IP datagram containing DNS query, that will be forwarded by a LAN switch from client to first hop router here, and the IP datagram forwarded from campus network, this is campus network, into Comcast. This one is internet service provider. Our case in our university, LGU Plus network. Routed tables created by those tables will be created based on that routing information protocol, open shortest path first protocol, and internet media system to intermediate system protocol. If we are using, then instead of this, LEC version 2, OSPF, or any one of them we may use, depending upon the Comcast policy, network administration policy. And also BGP, actually BGP version number 4, those are most commonly being used. Routing protocols to DNS server, and now that will be routed depending upon that optimum offered route that will be arrived there. And that will be demultiplexed. That means that will be sent to upper layer to DNS server here through this protocol stack, arrive here, and after that to this DNS server application protocol. DNS server replies to client to my notebook with IP address of this one. My local DNS server may request that. And now, this my notebook or my local name server, if we have, then that will ask to client with IP address of google.com. Thus, my notebook knows that information, IP address of google.com. Let's move to the next. The next step is here. To send HTTP request, client first opens TCP socket. HTTP is using TCP as we learned. Thus, TCP socket should be opened. To establish that connection, we need this thread handshaking first. First, TCP SYN segment will be sent from my computer, from my notebook, through this route. First, step 1. In thread handshake, interdomain routed to web server here. This is the web server. Web server responds. Google web server will respond with TCP SYN acknowledgement. The SYN acknowledgement will be back to my notebook here. The SYN bit and the acknowledgement bit, when you are observing with your Wireshark during your Wireshark lab, that will be 1. And finally, TCP connection will be established. Thus, after establishment of that connection, we can send that HTTP request message. Okay. Next step is here. HTTP request sent into HTTP that established TCP socket, and the IP datagram containing HTTP request routed to google.com, this web server, like this. And web server responds to HTTP reply. The reply like this, containing a page. IP datagram containing HTTP reply routed back to client. Here, and we can see on the screen in my notebook here. Okay, we just completed, and let's try to summarize. In this chapter 6, we learned about some principles behind the data link layer service. That is error detection mainly, and just a little bit about correction. Sharing a broadcast channel, multiple access schemes, among them we learned about that. And the link layer addressing scheme, we learned about that. And some instantiation example, and implementation of various link layer technologies, Ethernet mainly, and the switches, switched LANs and virtual LANs. Briefly, we learned about that. Also, some special network based on virtual circuit, and very similar to the virtual circuit of the packet network for virtual private network, VPN. And also traffic engineering, this one may be used. And finally, just we completed the synthesis a day in the life of a web page, of a web request of google.com. Let's take a breath. Journey down protocol stack we just completed, except physical layer. But physical layer is usually covered in the communication theory, and so many lectures are there about that communication theory, and those are also related to this physical layer, and some electrical engineering concept, those are explained mainly here, and data communication. That name, course name may be different, but those are dealing with this physical layer related concept. Solid understanding of networking principles, practice, and we could stop here, but lots of interesting topics. Thus, even though we are learning with just one single semester, and this book is probably for 2 semesters. Thus, in this 7th edition, chapter 7 is about wireless networking. And chapter 8, that is about network security. And the chapter 9, that is about this multimedia networking. Thus, if you are interested in them, then you can refer to them. Also in the 8th edition, just this one is using 8 chapters. Thus, after until 6, that is almost the same as we learned. But chapter 7 is about this wireless networking and mobile. And this one is related to that. And chapter 8 is the last chapter, and this security is so important, thus network security is covered here. That's it. Thus in next year, we may use this 8th edition for our textbook, and in Asia, that will be available probably at the beginning of next year. Until now, that Asia edition, that is not available in this year 2020. Thus, we use this 7th edition. Even though that 8th edition is available in the United States, if we are using that edition, and that is not Asia edition, then it is so expensive. If that is published in Asia, in Korea, then that will be cheaper than, thus that is affordable to use as a textbook in next year. Okay, that's it. For our final exam, until here, that will be asked. Also, even for the quiz test, until here, that's it. But we have something more. I put in some slides. Those are from 8th edition PowerPoint slides for reference, because that is available. Even though we are learning with the 7th edition, some good PowerPoint slides for better understanding about the current technology, that will be very helpful and informative. Thus, I brought here. Okay, this one is about data center networks and network elements. Something is very similar to the previous 7th edition PPT, but some contents are added. Thus, let's focus on that. This one is border routers, as we learned, and hierarchically this one is tier 1 switch, connecting to up to 16 usually. Tier 2 switches below. Tier 2 switches connecting to up to 16 usually. Tor switches below, like that. And this is Tor switch. Full name is top of rack switch. 1 per rack here, and depending upon the Ethernet technology and the standardization, completion of that standardization, this 40 gigabps and 100 gigabps may be used, but some standards for multi-mode of fiber optic cable, and that is being standardized, and that will be covered in the chapter that is explained in the chapter 6.6 but some technologies are not shown. There's I can show a little bit some introduction about current status. Around 2006, on July 18th, high-speed study group, they needed, and there was some call about their high-speed study, and that group was asked in the IEEE 8.3 plenary meeting in San Diego using single-mode fiber. And after that, around the year of 2010 and 2011, there are so many different standards, and using different standard code name, 8.3BA, 8.3BG, using single-mode fiber. Those are approved, and about 40 gigabps task force team, and about the standard code PJ, PM, CD, and so on, CU. But most recently, around June in this year, 2020, this is the status of current standardization. IEEE P 8.3 DB, that is the standard name for that task force. That task force started working to define a physical layer specification that supports 100 gigabps operation over one pair of multimodal fiber with a length up to at least 50 meters. Thus, still this Ethernet scheme, this protocol is being evolved. Okay. Thus this blade, each one is blade, as I mentioned already, that can be inserted here. Server legs, between 20 and 40 server blades. Those are hosted, that is Windows Server or Windows Server. This one is this one, or 2016, or those Windows servers and Unix server, Linux server can be inserted here. That is, each one is one blade. Okay, let's move to the next. Okay, this is also from 8th edition PowerPoint. Data center networks, about network elements, and this one is a new slide about Facebook F16 data center network topology. Here, this one is spine switch, spine. Okay, let's move again here. This one is spine switch. Spine switch, that means that is backbone. Backbone switch. In other words, they are using other word. Spine switch, fabric switch, and the top of rack total switch, and they are all interconnected like that. So complicated. This is also container-based modular data center. Usually, even Facebook. This one is social network service company, and Google, also this company, Microsoft. Those are all software-oriented companies, but they are providing cloud service, also big data related service. And this architecture, data center, modular data center design, that is purely hardware related. Even though that is hardware architecture, the software companies are concerning about that, because that cost, operating cost to manage, to use, to operate this data center is expensive. Cooling or ventilation and the architecture and the electricity consumption, those are all operating costs. And also they should change every 2 to the 4 or around 4 years. They should change that server, because server is becoming obsolete. There's new architecture, the server will be. In that case, instead of exchanging single server, the whole container around 40 feet and 12 meter, that container around a couple of thousand servers are here, that will be changed. If this one is not meeting certain threshold and it is below certain threshold value in terms of that performance, and that will be changed with a new container modularly. Thus this one is a kind of modular design, and that is container based. Okay, let's look at this one. This is about data center networks multipath for reliability. Each interconnection among these switches, LECs, as we learned already, increase the throughput between LECs. Multiple routing paths possible, and this one is showing that line for that redundancy. Increase the reliability via this redundancy. Think about this one, 11, rack number 11. Two disjoint, two separate paths highlighted between LECs 1 and 11. There's this one and this one. There's some application is running here and also here, and if it is not working, and then it will take care of that. That is reliability, providing reliability and redundancy. Also load sharing, load balancing, and that load can be distributed like that. And also some failure that can be used instead. That is also providing that reliability based on this redundancy. Okay, data center networks, application layer routing. This one is exactly same with our 7th edition slide, but let's read this one. Load balance application layer routing receives external client request, directs local load within data center, returns result to external client, hiding data center internals from client. Exactly the same. That is just being repeated. Okay, let's go to next. Okay, this one is probably a new slide introduced in this 8th edition. Data center networks protocol innovation. Data center is requiring new architecture for better performance and for better reliability, for the cheaper investment, and providing higher availability or reliability. And the link layer, you don't need to worry about this. Remote DMA over converged Ethernet, the acronym is here. That is being used as a new protocol, and this is called the protocol innovation. transport layer. This explicit congestion notification, even though in our plain transport layer we are not using, but this one, transport layer congestion control, can be used in this data center. And it is easy to use this one because that is administered by single administrator and a single policy in its autonomy. Experimentation due to hop by hop, back pressure, congestion control. And routing and management also new innovation. Software-defined network, even though that was pretty ideal, but that can be implemented in easy way in this data center. SDN widely used within among organization data centers. Place-related services, data as close as possible, for example, in same leg or nearby leg, to minimize tier 2, tier 1 communication. Okay, these some slides are just for reference, for better understanding about current technologies, and we'll wrap up here.